Hi, welcome to lecture number 10. This is about normal probability distribution. Recall back in lecture number 9, we've talked about binomial probability distribution. That's a probability distribution for a particular discrete random variable. And for a continuous random variable, let's have normal probability distribution. Normal probability distribution is actually one of the widely used and the most important probability distribution in statistics. At the end of the session, you should be able to, number 1, we will define normal probability distribution. Number 2, we're going to transform a normal random variable to a standard normal variable. I will explain that later. And then for number 3, we're going to compute for the probability of standard normal random variable. And lastly, we're going to solve some problems involving normal probability distribution. So what's a normal probability distribution? Well, normal probability distribution, or normal PD, is the probability distribution for a continuous random variable, or for continuous random variable. Normal PD is known for its many practical applications for continuous random variables such as weight, heights, and scores in exam. Let's take a look at some of these examples. So, for this one, this is the distribution of randomly selected 500 students on a particular examination. Yeah, so, ito yung distribution ng scores nila. Ito naman kabila, these are the heights of adult males in centimeters, and this one is the distribution of the weights of adult females in kilograms. 200 randomly selected, and for this one, 100 randomly selected males. The question is, ano yung napapansin nyo doon sa graphs nila? Well, actually, if you will notice, nilagyan ko siya ng ganito. Yan. Pansin nyo ba? Medyo pa ganun. So, imagine niyo kung pinadami natin yung mga estudyante na kumuha ng exam, tapos pinadami natin yung yung mga adult males na kinuhanan natin ng height, tsaka yung mga adult females na kinuhanan ng weight. It will somehow approach that particular curve or shape. So, for those type of datasets, yung mga datasets na ganun, yung nag-approach ng parang bell-shaped curve, okay? We say that those datasets are approximately normally distributed. And the study of normal curves can be traced back to the works of Carl Gauss. Actually, napansin nila, madaming mga continuous random variables ang ganito yung itsura ng kanilang distribution. So, of course, in real life, hindi naman talaga makukuha yung perfect na curve na yon. Pero, ang ginawa nila Carl Gauss, kinuha nila yung equation nung curve na yon, tapos yun, inaral nila kung ano yung mga properties na pwedeng makuha. So, ang ginawa nila, inaral nila yung mga curves na yon para magamit natin in real life. Although, yung perfect na curve na yon is actually, it only exists in a perfect world, pero madaming practical applications yon na pwedeng gamitin in real life. So, ito yung nagawang equation nila Carl Gauss. By definition, any continuous random variable x that follows the probability distribution function given below, this one, is called a normal random variable. Huwag kayo masyadong ma-intimidate dun sa equation. Ito, pi. Alam niyo yung pi. That's 3.14. Yung e naman, that's approximately 2.72. Ito naman, this one is sigma. That's for standard deviation. And for yung mu naman, that's for a mean. So, bawat distribution, merong they are being characterized by a mean and a standard deviation. So for this case, itong function na to, which when you plug this on a graphing utility, it will give you that particular shape. Pero nagbabago-bago yung mga shapes na yon. Depende sa value mo nung mean at nung standard deviation. So normally kapag yung standard deviation mo maliit lang, medyo payat yung curve mo. Pero kapag yung standard deviation mo malaki, medyo flat, medyo mataba yung curve mo. Ito, segue lang. A normal probability distribution can only be presented in functional and graphical forms. The question is, why? Bakit hanggang function lang tsaka graphical forms? Well, basically, they are continuous random variables. For a particular interval, sobrang daming data na makukuha doon. Daming points na pwede. Actually, infinite nga. So, for continuous data, hindi siya magandang gawan ng tabular form. Well, pwede naman, pero it will be, well, ang dami may ilagay din sa table. So, hindi siya practical gawan ng graphical form. So, functional na lang at saka, hindi siya practical gawan ng tabular form. So, in this case, graphical na lang at saka functional. And also, since a continuous random variable can have infinite number of values, the probability of a specific value is actually 0. So pag pumili ka ng isang point, kunyari, ang height ng tao, for example, is from 4 feet up to 7 feet. So for example, what's the probability that a randomly selected student will have a height of 5.3 feet, something like that? Well, the probability is actually 0. If you're going to just focus on that one, the probability is 0. But for this one, ang magandang tanong will be, what's the probability of getting a student whose height is between, for example, 4.5 feet up to 5 feet? Something like that. Okay, so the probability of getting the probability of a specific value in a continuous random variable is practically 0. Ngayon, this is basically the curve that you can get when you plug this particular equation sa isang graphing utility. So this one. So we call this a bell-shaped curve. Okay, or the normal probability distribution is symmetric. So ibig sabihin, what you see on this side, you also see on this side. It's unimodal. Meron lang siyang isang peak. It's bell-shaped. Yan, yung pansin nyo, it's bell-shaped. The area under the curve is equal to 1. So, kung hati ito, ibig sabihin, this one is 0.5 and this one is also 0.5. Normal PD is characterized by its mean and variance, sigma squared. Yung mean natin, it's located at the middle. The mean indicates the center of the distribution and the standard deviation determines its spread. So, what does it mean? Can we have different normal PD? Well, actually, yung shape, pwede. Okay, nag-iba-iba. So, iba-ibang mean, iba-ibang standard deviation, iba-ibang normal probability distribution. Parang kung pansinin mo kung sa real number line, umiipod yung mga normal probability distribution mo. Yung iba mas malapad, iba mas manipis. Depende sa mean at saka sa standard deviation. The area under the curve corresponds to the probability. The area can be computed using a technique in calculus called integration. So, graph mo, nung pinalat mo yung nung ginraph mo using the equation, meron siyang curve. In calculus, may dalawang big questions in calculus. The first question is find the slope of the tangent line that can be answered using derivative. And the other one is find the area under the curve, which can be solved or which can be determined using a technique called integration. But since we don't have that technique now, the good news is statisticians already computed areas under the curve, under the standard normal curve for our convenience, which I will show you later. Okay, so I was able to mention standard normal curve. So what's a standard normal curve? Well, a standard normal curve is a normal probability distribution with a mean of 0 and a variance of 1, or standard deviation of 1. Which look like this one. So the mean is 0, so in the middle, the mean is 0, and standard deviation is 1. Yeah, 1. Okay. The random variable that follows this distribution is the standard normal variable denoted by z. Well, balikan natin yung integration. Sa calculus kasi, pwede natin kunin yung integral nitong function na to. Evaluate, kunyari, for example, you want to get the area between -1 and 0. So you can do that in calculus using integration. Get the integral, then evaluate it from -1 to 0. You will get the area of this. But of course, we will not do calculus now. So ang gagawin natin, we will be using the table provided to us by the statisticians. And we have this one. So this is just part of the table. Ang binibigay sa atin itong standard normal distribution table na madalas na nakalagay sa likod ng mga libro, ang binibigay nila ay area to the left of a positive z. So what does it mean? Area to the left of positive z. So paano natin ito binabasa? Etong nasa left na column, dito mo titingnan yung first two numbers ng z-score mo. So, ito, mga z-scores to 1, 2, 3, 4. Normally, hanggang 4 lang yung visible kasi yung 5 nito, 5 standard deviations from the mean. Yung probability nun medyo sobrang liit na, practically 0 na yon. And then, to the left naman, hanggang -4 lang din yung halos visible pa yung area. So, ang binigay lang sa atin will be the area from a positive z-score to the left. So, yun yung pinrovide sa atin ng table. For example, to the left of 0.00, ay nga pala, itong namang top column naman, dito nyo titingnan yung second decimal. So for example, 0.00. So to the left of 0, alam natin that the left side will be 50%. So to the left of 0, so the area will be 50%. So let's have some examples. Use the table to find the area to the left of z equals 1.53. So ito, 1.53 is between 1 and 2. Ano daw yung area nito? Well, actually, the area of this one can be found directly on the table. Kasi nga, yung table, ang binibigay niya sa atin, will be the area to the left of a positive z value. So, paano natin yung gagawin? Una, kunin nyo muna yung first two numbers. So, in this case, 1 at saka 5, or 1.5, or the first, up to first decimal. So, 1.5, hanapin nyo siya dito sa left na column. you will see there 1.5. Tapos, yung 0.03 na remaining, hanapin nyo naman siya dito sa taas. 0.03. So, para lang itong multiplication table. So, kung saan sila nagtagpo, which is at 0.9370, that's basically the area to the left of z equals 1.53. Again, so we use this notation. The probability that z is less than or equal to 1.53 is equal to 0.9370. Okay. Yung normal na mga table na binibigay, yung mga one-page na table lang, binibigay na area sa atin. Ulit na ako. To the left lang nung isang positive z value. So, to the left lang hanggang 3.99. 3.99. So, hanggang 3.99. Let's go back here. Bakit? Kung pansinin nyo, yung 3.99, halos 1 na yung area, no? 1 na. Actually, 1 na nga to. 1.00 something. 3.89 nga. 999 na yan. Okay. So, nagsimula tong 999. Nagsimula siya dito. So, 3.60, 3.65. Ibig sabihin, at 3.65, mga banda dito, the area to the left of that z value, 3.65 is 1. Okay, 1 na. So, hanggang doon lang yung binigay sa atin. Yung ibang table, yung mga unang table, kalahati lang nung area yung binibigay. So, hanggang 0.5 lang sila. Kasi, ikaw na lang yung bahalang kumuha ng kabila kasi mirror image lang. Remember, symmetric to with respect to the vertical axis na dadaan dun sa mean. Okay, so let's have this example. We have a normal probability distribution, or a random variable is normally distributed with a mean of 25 and a standard deviation of 5, just like this one. So ito yun, yung mean niya 25, nasa gitna yung 25, tapos standard deviation ay 5. Kung normally distributed to, yung visible sa atin na may area pa ay hanggang, actually 3 lang 3 or hanggang 4 na standard deviation. So, plus 5 ka ng plus 5 dyan. Tapos, sa left naman, minus 5 ka ng minus 5. Hanggang 5 to. Okay. How do we determine the probability of your random variable? Or how do you determine the probability of x that is less than or equal to 23? Ang binigay lang sa atin ng table ay hanggang 3.9. Or mga values from negative 4 to positive 4. But this one is 5 to 45. So, wala tayong values for this one. So, ang gagawin natin, we're going to convert those values into standard z-scores. So, if you'll notice on this figure, yung 25 mo corresponds to 0, 30 corresponds to 1, 35 to 2, 40 to 3, 45 to 4. Well, it's not very difficult to see what is the formula for converting this. Kasi, to get 0 to get to 25, 25 to get to 0, you just have to subtract 25. So, alam na natin na magsusubtract tayo ng mean. So, 30 minus 25, we have 5. Paano magiging 1 yon? So, basically, we just have to divide it by 5. 5 is your standard deviation. Okay? So, 40 divided by, 40 minus 25, that is, what's 40 minus 25? That's 15. Divided by 5, that's 3. So, this is your formula for converting a random variable x into standard z-score. So, tandaan nyo to. X minus mu divided by standard deviation. Again, kanina, given tayo, we have a normal distributed, we have a random variable that's normally distributed with a mean of 25 and standard deviation of 5. How do we get this? So, we just first write that. We want the probability that x is less than or equal to 23. And we can all, of course, convert that into z-score using the formula x minus mu over standard deviation. So everything, you just have to plug in 23 minus 25 divided by 5. 23 minus 25, that's minus 2 divided by 5, that's negative 0.4. So we have to get the area to the left of a negative. Wala tayong ganun sa table natin. Tama? We don't have those areas sa table natin. So, paano natin kukunin yung negative 4? How do we get negative 4? Well, the probability that z is less than or equal to negative 4 is equal to 1 minus the probability of z less than or equal to 0.4, which is the positive 1. Bakit kaya? Well, if you're going to look at this one, for example, if you have a normal distribution, hindi ganun kaganda yung drawing ko, tapos you want the z to be less than negative 0.4, no? So, ito yung kailangan natin. Negative 0.4, and we want this particular area over here. But the table will not provide us with this data. Pero ang alam natin, since your distribution is actually symmetric, alam natin that at this 0.4, positive 0.4, this particular area, which is gray, is the same thing as this area, is equal to this area over here. But the problem again is, hindi ibinibigay sa atin to ng table natin. Kasi ang binibigay lang ng tables natin ay yung to the left. So, ang binibigay lang ng table sa atin is actually to the left of 0.4. So, ito. 0.4. Ang ibibigay sa atin ng table will be this. So, the question is, how can we get this particular area over here, which is the same as this one, and also this white area over here. Okay, you're actually correct. All you have to do is to get this area, and subtract it from 1. Tama? And that's basically what's written over here. So all we have to do is to subtract the probability that z is less than or equal to 0.4 from 1. And by looking at the table, 0.4, balikan lang natin, 0.4. So let's 0.4. So 0.4 hanapin natin. 0.4 is 0.40. So 0.4 and then sa taas titingnan natin is 0. So for this case, 0.4 and then 0. So the area is 0.6554. Which is this one, 0.6554, and subtract it from 1, we'll get 0.3446. Therefore, the probability that x is less than or equal to 23 is the same thing as probability that z is less than or equal to negative 0.4, which is 0.3446. As I have mentioned, yung z-table na ginagamit natin will only provide you with the area to the left of a positive z. So, ibig sabihin, ang ibibigay lang niya sa atin ay lahat lang ng to the left of, for example, positive 1. Yan. So, ang ibibigay niya sa atin, yung area to the left of this. Ngayon, yung nangyari sa previous example natin, what if to the left of a negative? So, to the left of negative 0.4, di ba? Negative 0.4 yan. Negative 0.4. To the left of negative 0.4. Ang ginagawa pa natin, we subtract the area to the left of a positive 0.4 from 1. May mga z-tables na nagbibigay din ng area to the left of a negative z value. Kung available yung ganong mga table sa inyo, well, you can use those things. Mas madali. For example, itong z-table na to, meron siyang hanggang negative 3.99 to the left of this. So, pag tinignan natin to the left of negative 0.4, the answer is 0.34458. Yung sagot natin kanina is 0.34458, di ba? 46. So, kung available sa'yo yung table na merong negative z value, you can use it. Pero, paano kung hindi available? Well, paano kunyari, ang na-provide lang sa atin na table ay yung to the left of a positive z. So, mahalaga rin na alam natin kung paano siya gamitin ng tama. Pero kung available yung may to the left of negative z, gamitin nyo na lang. Mas madaling gamitin yan. So, ito, paano kung to the left of a positive z lang yung given? How will you get the probability of z greater than a positive z? So, ito yon. If it's greater than a positive z, again, ang given lang sa table natin ay to the left of a positive z. So, all you have to do is to subtract the value of z to the left of that z value from 1. So, in this case, for example, if we want to get probability that z is greater than 1.23, kunin mo na lang yung area to the left of 1.23 and subtract it from 1. So, in this case, the answer is, to the left of 1.23, it's 0.8907. Let's take a look sa graph natin. 1.23, no? 1.23, so we have to look at 1.2 and then 3. 1.23, so ito yon. It's 0.8907. And then, we have to subtract it from 1. So, the answer is 0.1093. So, that's 1. If it's greater than a positive z. Ito, alam na natin to. Less than a negative z. If it's less than a negative z, it's the same thing as getting the area to the right of a positive z. Kasi nga, mirror image lang naman. Symmetric siya. So, all we have to do is to subtract the area of z to the left of positive z from 1. So, for example, if we want to get the probability that z is less than negative 1.23, all we have to do is to subtract the probability of z less than 1.23 from 1, and we'll get 0.1093. Ngayon, tingnan natin if this area is equivalent to the area na ibibigay sa atin kung gagamitin natin yung z-table na may negative z value. Negative 1.23, no? So, negative 1.2, and then 3 is here. So, ito, 1.223. So I'm guessing it's 0.1094. 1.094. Oh, ito, 1.093 yung given. Okay, syempre may mga round off na dun sa dulo. Kaya na nakukuha natin is 0.1093. Okay, pero to okay lang. Okay yan. Okay pa lang. Okay din yan. So that's case number 2. Yung case number 1, greater than a positive z. Case number 2, less than a negative z. And case number 3 will be greater than a negative z. So if it's greater than a negative z, equal lang din yun sa probability that z is less than z. Kasi, kunyari, negative 1.23 to the right, equal lang din yun sa 1.23 to the left. Parehas lang yung area nun. So, kunin mo na lang yung 1.23. At lastly, case number 4, what if it's between two z values? So, if it's between two z values, all you have to do is to get the probability that z is less than b, yung mas mataas na number, minus probability of z less than a. Obviously, kung kung mga negative at positive, at gagamit ka ulit ng mga previous cases, gagamitin mo ulit mga previous cases. For example, if you want to get the probability that z is between negative 1.23 and negative 1.23 and 1.23, all you have to do is to get the probability that z is less than 1.23, the positive, minus the probability that z is less than, yung value ng a, which is negative 1.23. Ito, madali lang. You can just directly look at the table. The answer is 0.8907. But however, itong probability that z is less than negative 1.23, you will still be using case number 2, where you have to subtract it from 1. So, ito yung nangyari dito. So, the answer is 0.7814. Okay, let's have this example. Given mu equals 25 and the variance is equal to 9, find the probability that x will be greater than or equal to 30 provided that that particular distribution follows a normal distribution. A normal distribution has a mean of 25 and a variance of 9. Find the probability that x will be greater than or equal to 30. So in this case, let's first write the given values. 25. Oh, ito. Bakit nga pala ito naging 3? Well, because it's the standard deviation. We have to get the square root of the variance, which is 3. And we want the probability that z is greater than or equal to 30. So in this case, we will be using the formula. Remember the mu minus x divided by 3. So ito yon over sigma, or the standard deviation. And the answer is z is equal to or greater or equal to 1.67. And then we want to get the area of z greater than equal to 1.67. Greater than to, so we'll be using case number 1. So in this case, all you have to do is to subtract the value of that z is less than 1.67, and the answer is, check nga lang natin kung 0.9526 to. Remember 1.67. 1.67, all we have to do is to look at 1.6. Here is 1.6, and then 7. Ito yung 7. So 1.6 and 7 is 0.9525. 9526 dito. Bakit kaya naging 9526 dito? Pero dito sa table natin is 9525. Walang 9526 dito. Feeling ko, ang ginamit ko dito yung GeoGebra at yung Microsoft Excel. I'll show you how to get the area using those software, GeoGebra and Microsoft Excel later. Pero ito okay lang na gamitin to. Tapos nung sinubtract ko, it's 0.0475. I think this is 5. Okay, this should be 5. Okay, may typo error. But anyway, how about this one? Find the probability that x will be between 15 and 30. So if it's 15 and 30. Again, we have the same given value. The mean is 25 and the standard deviation is 3. We want this. Kung ito yung mangyayari, you have to convert 15 and 30 to standard z-score. So 15 minus 25 minus the mean divided by the standard deviation. The answer is negative 3.33. And then 30 minus 25 divided by 3, the answer is 1.67. If it's between two z values, I have typo errors here. Dapat to less than. Should be less than. This one less than. So, this is case number 4. Tama ba? Case number 4. So, where you want the probability that z is between two z values. So, all we have to do is to subtract yung 1.7. Yung mas mataas muna, 1.7 minus the probability that z is less than negative 3.33. Okay, typo error dito. So, let's get the value of 1.67. We were able to get that. 9525 talaga dapat to, no? And then, less than 3.33. So, let's look at 3.33. This is 3.3 and 33 is here. So, 0.996. Okay, tama. 0.996. And yeah, the answer is 0.9521. I hope tama to. 0.9521. Let's check. The answer is 0.9522. This one, corrected na to. So the answer is 0.0475. And this one is 0.9521. Kasi binago ko na yung area ng 1.67. It's 0.9525. Okay. Okay, before we proceed, let's have a review. To find the probability of x in a given interval, we will follow this process. The first one is, of course, you have to list all the given values. Find the mean, the standard deviation, or the variance. So, of course, standard deviation yung kailangan mo. Kung variance yung given, you have to take the square root. Kung standard deviation, wala nang problema. Transform x into z using this formula. Okay? And then locate the computed value of z in the z table to get the probability. Using all the cases kung kailangan mo ng cases. Again, kung given ka nung z table na may negative value to the left of negative z value, walang problema, you can use it. Pero tinuro ko sa inyo yung mga ways at saka yung mga process na to, this one, itong mga cases na to. Para just in case, meron yung table lang na yun provided sa inyo, you can still get the area. Okay, if you notice, sometimes I use less than or equal at saka less than, katulad dito. Saan ba yun? Ito, greater than or equal, pero ang area na nakuha mo, ito naging less than na lang. Okay, for example, ito, negative, less than 1.23 or less than equal to 1.23. So, ginagamit ko siya interchangeably, but same lang yung nakukuha nating area. It's because the only difference between these two is the inclusion of that particular point. For example, z less than a particular, less than or equal to a particular z value. Ibig sabihin, included yon. But if you get the probability of that point, for example, if you want to get the probability that z is equal to z, well, the area is 0 because this is continuous, no? Walang probability yung point. Okay, the probability of a specific point is actually 0. So, ibig sabihin, yung probability nito at saka nito ay parehas lang. So, paano sa computation? Kung ang given sa inyo is this one, then you have to use less than or equal. If it's less than, then use less than.